Good morning.
Good morning, ma'am. Good morning, ma'am.
Good morning, ma'am.
Sridhar ma'am, proceed.
Yeah. Shall I start, sir?
Yes, ma'am, proceed.
Okay. A very good afternoon to one and all present over here. Before I take you through the journey of today's session, I just wanted to share a small story with all of you. It was a story of a 9-year-old boy who was sitting in his math class. He was extremely bored and was goofing off and getting into trouble. The teacher was really angry with this boy for his mischief and he wanted to punish him. The boy was called by the teacher, and the teacher told him, "Go to that corner and sit and find the sum of the integers from 1 to 100." The boy, he didn't pick out any pencil or a book. He went to the corner and just sat there. The teacher confronted the boy. "Are you working? Are you ready with your answer?" The boy said, "Yes, sir. The answer is 5050." The teacher could not believe that the boy had given the right answer. The teacher himself took 10 minutes to solve the sum and then realized that the boy was right. Children, you know who this boy was? He was none other than the famous mathematician Carl Friedrich Gauss. So Gauss had a creative solution for the problem that was given to him, and he found a pattern and arrived at the right answer. So, in today's session, children, you will be introduced to a platform where you are given an opportunity to work on your creative solutions. And not only on your creative solutions, but also you can share your solutions with others. Not only this, it also gives you an opportunity to experience a joyful learning of mathematics. And the platforms which you are going to be on would be the Inc. platform from Bangalore, Blended Learning from Hyderabad, and PolyUp from US. So before we start with the session, I would like to talk a few words of Miss Lakshmi, who is the CEO of Inc. Ms. Lakshmi, penchant for community building and technological innovation, has led her to found Inc., which stands for Innovation and Knowledge. As a speaker, Ms. Lakshmi addresses large corporates and leaders where she instills cutting edge insights and moonshot style of thinking to bring innovative business practices into the company. It gives me an immense pleasure to call upon Ms. Lakshmi to continue with the session. Welcome, ma'am.
Thank you very much. Good morning, everybody. And we're very excited to bring this new program to you. And as Ms. Sridevi was saying, one of the things that's most important is the ability to answer innovatively. It's not just about solving math, it's about thinking of the big picture. And most of you are going to be in 6th, 7th, 8th, 9th grades. In the next 3 to 5 years, when you go into the world of college and high school, etc., not going to be just being experts at one subject. We want all of you to become great leaders. And to be great leaders, you have to know math, you have to know business, you have to know entrepreneurship, you have to know what it means to do something that matters to the whole world. So the United Nations has come up with something called development goals, sustainable development goals. The idea is, how does the whole world become equitable, be it for law or be it for human rights, be it for education, be it for water? There is 17 different aspects. So the United Nations said, how do we bring the whole world together on these 17 aspects? So, what we are doing is that we want each of you who's going to be part of this program to be a great leader who can not only think of how to solve a problem, but how does it matter in the large context, in the larger world. So, we are very excited. This is something that we are on a journey with the students, the parents, the larger community. There'll be lots of things you'll be doing where you need to survey the community around you, talk to people around you. So I wanted to say the goal of this program for us is to create wonderful leaders. And we have a whole year-long path where you will be doing various things through which ultimately the best student, best ones who win are going to end up with an entrepreneurial program with some of the best people who have been successful in the world of business around, mostly in Silicon Valley. So I have to introduce to you someone. Um, we talked about three partners. We talked about blended learning, and we talked about Inc., which is our organization. And the third organization in this is Polyup. And Amir is the CEO and co-founder of Polyup. And he's somebody who has been an entrepreneur many times. He started over 7 companies, sold them very successfully, been extremely successful. But his beginning was in being a teacher. He received his, he used to teach math and physics at UCLA, University of California, Los Angeles. He received Teaching Excellence Award for math and physics at UCLA. He received his PhD in theoretical physics, master's in EE, MS in physics. I mean, after doing all this, he started many, many companies, had very successful exits, and he went back to his math teacher and his 19-year-old son, and together they started this company, Polyup. So I would love to have Amir come on board and tell us what we are planning to do right now and why we feel this is important for all of you to learn about humanity and about how you can each become wonderful leaders in this new world. It's not just about any one subject excellence, it's about a holistic development. With that, Amir, it's all yours.
Thank you, Lakshmi. Really appreciate it. Thanks for your kind introduction. And I'm very glad to be part of this wonderful event. And I want to share with you all that, we just got to discuss to have the program, what we call national and global challenges, to run for your community and your school just about a week ago. And just how rapidly this has been put in place is a testament to the leadership and also the strong background that your school and you, especially the kids in the school, have shown. I had a pleasure of having the discussion with 8 of the students from, I think, 6th to 9th grade a few days ago. And just in matter of about 45 minutes discussion we had, and we had some problem solving fun together. It was amazing to see how well you have got ready to do this kind of problem solving. Just how fast the Inc. together with your school have been able to put this together to start from next week is just amazing. I can tell you that this has been the fastest turnaround to have a national challenge, to start in a country, that now your school is going to be the one that actually pioneers it for the rest of the students in India. So first of all, let me say no pressure. You are leading the other students in your country to have such activity, so that should be fun. The platform I want to show you is right now is getting used in more than 70 countries. It really started from Stanford. It started from a math teacher and a math student. And the map you see here these days, it looks like a COVID map, but actually is where Polyup is getting used. Most of the usage you see here is organic, and more than a million of what you will see activities, or soon you will see them as machines, has been created by students and teachers around the world, has been shared more than 25 million times. They have been played, and the community is growing very rapidly. What the goal is in all this is to have a connection between what you're learning in school and what you can do in real life.
Yeah,
You
Amir,
know,
can you please check your chat?
Sure. Let me make sure I have the chat here, because I have so many other things here. Okay, very good. Thank you. So as I was saying, the main point here is to make a connection between the skills, the math, the science that you're learning in school and real life. You know, as my own personal journey, you know, my study has been in particle physics, in physics and science, and I have done many companies. And believe it or not, that education and that what I learned is what actually I'm using every day to make these companies in Silicon Valley successful. So it's not just a nice thing to say that there's a connection there. I have seen it in my own journey that how critical is what you're learning to get applied. But what I didn't have as a child at my hand is how to apply what we learn now to the real life. It took me a few, 20 years before I get to real life and can start to apply what we learn in school. So what really the goal is in Polyup is to enable you to apply what you learn now today, whatever grade you are. You're in 6th grade, you're in 9th grade, today, immediately now, how can you apply what you learn to solve real problem, local, in your home, in your school, in your city, in your country, or global challenges. And that's wonderful. It doesn't need to wait. So that's kind of give you an overview. From that, I want to dive into and show you some examples. And the goal is over the next, say, 20, 25 minutes, have a little bit exercise together to get a taste of what will come in a program which is going to take about 7 weeks. And that is the start of a journey. This 7 weeks is the first challenge, and it will continue. I'll talk about other program that follows that. Really, what I can summarize this is how you can code with math. And we all learn that coding is important, and we all want to learn and all those. But actually, the fundamentals is even more important. The language of coding. If you know math, you can actually discover sciences. You can make green energy. You can build a smart city. And this is not just something to say to feel good. Is an actual reality. And in this environment, we'll show you that actually with the math expressions, you can achieve that. It is all about building, and you'll see that you're going to build yourself. It's not just a problem somebody provides to you. Actually, you build puzzles, you build simulations, what we call machines, and you share with others. And the sky is the limit. Anything you can imagine, you can build. Right now, you are the 6th country that you're deploying this. This is right now the challenge going in US, going on in Oman, in Azerbaijan, in Rwanda, in Kenya. There are many countries are starting and doing this. And of course, you're as one of the early countries that they're doing this systematically through challenges. And finally, what's very important is none of this we do in vacuum. Any kind of invention you do is for betterment of our community at whatever level, from the local level to the global level. And that sharing is critical. So with that, what I want to show you first, I want to show you a 1 minute of video, which is kind of summary of what Polyup is. And whatever you see here has been built by students and shared with each other. So it's a 3D environment. The best way to explain it is something like a Minecraft, which I'm sure you all know. But at the same time, you can see the power of a Scratch. And at the same time, you actually don't need to code, and you use all math. So everything you will see that has these chips on them, these chips are what they have math in them. So let's see some examples and I will come back.
Polio, it's now in 3D, so it's time to throw a mathy party. Polio, it's your favorite playground. Modify with math to make the world go round. You can mod the world with the power of math. Just switch out a block to make the block switch its path. Is that Flappy Bird? I just built it yesterday with the power of Polio. You can build games your friends can play. Well, how do you do that? Well, it's just drag and drop. No need to type a code, use what you already got in your brain. That's the aim, you know? Math ain't lame. Get up, get out, and get started on this game. You can build a city skyscraper or a New Year's celebration. The sky is only limited by your imagination. Ever thought you wanted to lend a hand? Well, now you can build it and wave to the fans. You can even build a plane that flies, or take one that exists and make it cooler than the other guys. Polly up. It's now in 3D, so it's time to throw a mathy party. Polya, it's your favorite playground. Modify with math to make the world go round.
So as you see, there is no limit in what you can build. The type of environment is such that it scales from elementary school, can go all the way to university. You can do 1 + 1 and be in kindergarten. You can go all the way from arithmetic to pre-algebra, algebra, pre-calculus, advanced calculus, differential equations, and go all the way to statistical analysis and even build example products in the same environment. So I want to show you from very simple, like elementary examples. You know, you have calculations, simple calculations. And those chips that you saw are where the math is, and that math can do just math or can do math and move things around. So I'll tell you a simple example just to see what's the rule of the game. Here you see in the chip, you have 7, 2, and a plus. And in this system, instead of saying 7 + 2, you say 7, 2 plus, and plus each 7 and 2 and give you 9. Simple game. That's the rule of the game. So if you have in the same system now, in this stack, you have 3 numbers on a stack. For example, you have 8, 5, and 1. Then plus each 5 and 1 give you 6. And then 8 and 6 gives you 14. That's just the rule of game. I'm sure this is very simple for you. And this, here you go. It can generalize and can go forward. Now, those operators can be anything. The operator can be plus, minus, can be integral, differential, and one fancy operator can be, you know, Jacobian or whatever you want to say, even in a higher level, and can be also a representation of some physical impact. So if you talk about robotics, it can be about like going forward or going right. And the same way that you have here, you can have 2 go forward and 1 go right, which means this robot will go 1, 2 forward and 1 right and will hit the goal. So there is something fundamentally here makes math and its application one and the same. 1 + 1 is nothing more than 1 step forward, another step forward, and 2 step forward. Now, this goes at the more level of now middle school. You can have variables, you have other function, you can have x, you can have functions. Here, the column 2 is a function, and I call it here. I take the value 5, put it in x, then call the second function, which is the second stack. Now, 2 and x is the value 5. 2, 5 multiply. You remember multiply is at the end. Multiply each 2 and 5 give you 10. 10 and 1 gets eaten by plus and give you 11. The same way you can go forward, you can have loops, and you can apply those in very real life problems, actually important problems, like sustainable goals. These are a set of the sustainable development goals which Lakshmi mentioned, which is very important, and various countries, every country constantly is trying to achieve those, like gender equality, water resources, green energy, eliminate poverty. These are all the goals that constantly we are striving to do better. And I want to show you an example of how a student have actually took one of these. What I'm going to show you is a 5th grader in the US that has thought about what happens like in gender equality, has researched about it and made a research. So I'm going to show you a minute of video about that.
So this is a gender violence machine, and I'm going to do the first chip of it and show it to you guys. All right, so this one is about gender violence worldwide. More than 1 in 3 women have experienced gender violence at some point in their lives. Since women represent 49% of the global population, can you calculate how many women have experienced gender violence? All right, now it's calculating the world population. 10 to the power of 9 is 1 billion. 1 billion times 7.7 is 7.7 billion. Now it's finding the woman's population. 40 times 49 divided by 100. 1 divided by 3 is the ratio. Multiply those two things together and you get 1.26. E plus 9. Do you realize how much this is? This is 1.26 billion women have experienced gender violence in the entire world. That is more than about like 4 or 5 United States of Americas. And this is completely humongous compared to the amount it should be, which is nothing.
So that shows you examples of how students actually build their their projects. Those are examples. And then you continue, you go to high school side, you talk about probability, advanced algorithms, and here you can have full robotics, with the difference that you don't need to go buy a set of the robotics, for example, Mindstorm from Lego or some other robotics set and put it together. You can actually build whatever you can imagine and move them around, again, by more and more math that actually look at this as a system, which is very important, because in the many of the coding that you have seen is more about, if you have seen or done, which I'm sure many of you at some level are doing, is more about just learning how much more code you can write to make something complex happen. But actually, when you get into see how many of the technologies come out, they're not about doing a very complex thing and write a gigabyte of code. They're more about how to design a system which has many parts, and you put the parts together and you design carefully how each of the parts has to play its role in an overall system. And if the design done right, even though each part of the system has a simpler behavior, when you put it together, they can achieve a very complex goal. That's what internet is. Each of the switches in internet, actually, they're not complex. But when you have, tens of billions of these switches and they do routing, you achieve something very complex. So those kind of things actually can be modeled here. And in addition to that, you can do what entrepreneurs do. They do design thinking. They go through iterations. They come with idea and test it. They share what they built to make sure the prototyping is good. you're going to be able to do that. So let me jump in and show you the environment. We are right now at a very rapid speed trying to bring the India challenge up. Is going to be up by around Tuesday. So what I'm going to show you is what happened in one of the other countries. Like I'm showing you right now what's happening in Kenya, because that one also is English. So you're going to have an access to be able to register to go in an environment like what I'm showing. And then when you log in, you're going to be in an environment, there's a dashboard, and this challenge right now is at the level of a set 2 activities. And when I go there, I see those activities I have for a specific grade. And these are the activities. What you see here are the actual machines, as we call them. Each of them is a specific activity. And you're going to be able to go and do those activities. So I'm going to very rapidly show one example. Like I'm going right now inside a machine. This machine, every machine is a 3D environment. So I have to log in here. Let me make sure I can go in. So every of these machines is a 3D environment. And in that 3D environment, you have 3D objects which you can move around. You can turn them with 2 fingers, and you can go inside one, and you can make them go inside the chip. And inside the chip, you have the math. For example, here, every time you go inside the chip, you click on poly, and you see it runs. It always runs top to bottom. And as you see, it starts, it goes down. When it hits the minus, it's 4 and 4, which is 0. Again, 4 and 4 minus give you another 0. And the plus 0 and 0 give you 0. But Paul is not happy. Paul wants 1. So you go back, you have some operator at the bottom, you do some change. I'm killing the fun for you. You can do it yourself. If I here put a multiply and run, now 4 times 4 give me 16. 4 minus 4, not the right answer. Mistakes has no penalty. I can do a mistake. I see, oh, I didn't get 1. I go back. Oh, actually, I want to do divide here. So now I go, and when I do this, I get 1, which is the right answer. I get 10 coins. Keep in mind, these coins gets add up. They turn to something which called XPs. And I'll come back to XPs in a second. Now, one thing keep in mind, this is like real life. We're not asking you what's the answer. We're giving the answer. You know you want to go to the moon, or you want to make money, or all those, or make this startup successful. It's about finding the path to do it. So here you found it. And you know, just like real life, there is no unique way to do it. There are different ways to do it. I can put a multiply here. I can put another multiply, and then I can make it to be divide. So now if I run, 16 divided by 16 give me 1. So that was one example. If I go back, I see that the various machines, they have a multiplier. Like for example, the machine which I just played with has a multiplier 10. So those coins that you saw, the 10 coin I got, it will multiply by 10, become 100 XPs, experience points, and experience points adds up. Experience points are important because I can get badges, certificates, and also their leaderboards. I will come back to that in a moment. Let me take you to another example. Let me go another example here. This example, now you are in a 3D environment that you can actually do movement. So again, it's 3D. I can move. I can turn it around. And the goal here is to go and hit each of these flags. And right now it hits the first flag and turn 45 degrees in the wrong direction. I want to turn 45 degrees the other direction. I want to do this 3 times. So if I go back, I go inside the chip. This is not turtle chip. Turtle chips move things. It still is math, but they move. And they're doing something interesting. You see this double dot? It's calling this column. I can actually take more of this, call it twice, and call it 3 times, and call it 4 times, because I want to go around the square. But by the way, I don't want to turn right. I want to turn left. So how about if I turn left here instead of turning right? And 45 degree was not right. I want to do 90 degree. If I turn 90 degree, now every time I hit the column 2, it's 5 step forward, 90 degree turn to left, 5 step forward, 90 degree to left, and it does it 4 times. So if I go back and run it, I see now I'm going to achieve all 4. Okay. If any of you right now feels that these are too simple, hold your thought. These are basics. So I want to go back and show you that actually you can do much more than this, even if I go back to the same one. And let me do a search here. There are many machines. So I want to show you, for example, here, if I go to, let me go back and give you an example here. So let me show you an example of the machines that the kids built, okay? So this is a machine that in another country, a 9th grader have built. So I'm going to show you can build those. In a second, every element that is here is put together by the student. You can build all the machines that I showed you till now, you can build yourself. And in this case, this student has put these cylinders together that make feet. There are some cubes, make a body. There is a head, which is sphere. And then it put chips to run them. I'm going to just show you what it happens here. So now you have a humanoid that is doing figure skating. All part of the body is moving. This is a complete robotics. You know, before such an environment, you have to go to MIT lab and learn robotics and sit down to do such a kind of thing. You have to learn programming, and I don't know, Python is not enough. Actually, you should know 3D. You have to do Unity. I mean, all these names that you can jump around and say. And when you have those, you have to write a lot of codes. But you know what we forget is if you go back to the foundations of your computational thinking and the systems thinking and get the math you learn actually to work, building such a thing would not be thousands lines of code. Actually, if I stop it and go in, you can see that each of these chips have very simple description. This actually use a cosine. In higher grades, you are going to see that, but it has a time pi multiply a cosine 1.2 multiply and rotate this much degree. And if you run, you will see time is 0, time 0 times pi is 0, cosine of 0 is 1, 1 times 1.2 is 1.2, and it turns that much. So that was one element of this system. I didn't need to write, you know, hundreds line of code, but it was very important to model the movement of the feet in the body. And for doing that, you use the part that seemed to be the most boring part of the math, that oscillatory functions like a sine or a cosine. So you will see that actually now every aspect you learn in the math class or in a CS class actually can be leveraged to build the model of the next invention you want to do. It doesn't matter is robotics or is a smart city or whatever next thing that you you girls and boys are going to pioneer. So let me jump into showing you how you build such a machine. So if I go back to the environment, you see that when you get to the week that you can make machines, and that's the week 4, I'll discuss that in a second. Then by doing a machine, I can here make a best India machine, and you see that you have an environment that actually give you that environment of 3D. Again, you can move it around, you can turn, you look at it from different angles. There is a cube here I can move, and this cube has one simple chip on it. And this chip actually says 2 steps forward, 1 step right. So just like if I run it here, I can see the math, how does it work? If I go back, it will go 2 steps forward, 1 step right. You see the units, this is X, this is Y. So now you can see that I have all sorts of libraries. They have different libraries of different objects. I can bring like a hand and connect it together here. I can bring another hand and connect it here. And I can put this turtle chip in front such that I can now put a head for my robot. Let's have another part of the body. And now I have a robot that I can make it around. Let me make this go around. So I have a chip here. Now I can make it such that this chip actually move me over an octagon. So let me do an octagon. So first of all, octagon has many sides. So it's better to actually not put here. I'll put it here, make the octagon be a size of like say 4, and make it to be turning as much as say, for example, I want to make an octagon. So actually it has to turn every time 45 degrees. And then I have to put this function run and maybe more times to run. Now I have to put 8 times to run. And let me put here, there are interesting ways you will learn how to shortcut that, but let me put my 8 here right now. This is 6, 7, and 8. I want to draw the path. So the drawing the path is this operator. And I want actually every time go 1 step up. So I go here and go 1 step up. So not only I'm doing 45 degrees, every time I go 1 unit up. So let me go see what happens. So now I have my robot is going forward 5. Every time turns 45 degrees to right, but goes 1 step up also. So you see, if I see it from the top, it draws my octagon. But if I look at it from the angle, it actually makes a 3D path. And you know, there is no limit here. You can build these robots. I can make a city of this robot. I can drop this here and drag it, many of those. Now I have a city that runs those. So all of them running together. So this kind of environment is just amazing. I want to show you in another country what kids have done. So let me go here and, for example, show you that what the kids did in Oman. They built some amazing machines like here. So these were 9th, 10th, and 11th graders. And this was just May to June. They had a 5 weeks, not a 7-week program. Yours is 7-week program. But here what you see, a 10th grader has made a machine about racing. And this is another puzzle. This is a game that you calm down. And then, you know, it just, every movement you see, even the movement of camera is with math. Here is turning fishing into a math problem of angle and length. So in that challenge, and you see here is a full 3D game somebody made. I mean, in that challenge, we had building game as the goal. This is simulation of autumn when the leaves are falling down. In newer more recently, we are actually putting SDG as the goals. You are going to have SDGs, the Sustainable Development Goals, as the goal, which actually now you can have more meaningful machine. Here, this is actually a recreation of a Minecraft game, a famous Minecraft game that you usually play in the server of somebody else. Here, actually, the student recreated the whole game and put the math for it. So the sky is limit. I mean, it goes on. And I'm sure you're going to do even more amazing machines after you get into this. There is no limit on how you should do it or what you should do there. The only limit is actually your imagination.
Amir, sorry, I just wanted to say to all the students here is that, Amir has shown a lot of things that may seem easy to some of you, may seem complicated to some of you. There is only one thing you need to remember, which he said in the end, is that, there are many programming languages. There's Python, there is something else. There, in old days, there was Java. So every time a programming language changes, you need to learn that programming language. But the way you learn it here that he's talking about, the programming language doesn't matter. No matter what the programming language changes out there, it doesn't matter, because you are learning the math that's behind it. You are learning the language that's behind it. So this challenge is to see how well you can think about the fundamentals and create solutions that can solve big problems. So he's going to say a little bit more about, there's going to be beyond math. There are other aspects also. So just wanted to say, don't get, a little bit upset by, oh my God, there's so much detail. This, for all of you, in 1 or 2 sessions, you'll know everything really well. But the idea is that to make you understand the fundamentals. That's exciting here.
That was very good. I appreciate it, Lakshmi. So you have 7 weeks. It goes gradually. Not everything happens at once. It actually, these 7 weeks is the first part. Yours actually starts from next week. The date you see here, November 2nd, is for some other countries. They started a few weeks earlier. Yours will start next week. But there is a 7-week program, actually. There would be another one in spring and in summer. And what happens is, through this 7-week program, there is leaderboards at the national level, and the schools that right now are online, you are the pioneers. Still, you're only few of the schools among, I don't know, million of schools in India. So it's really on your shoulder to take this. And at the end of the 7 weeks, actually, a number of the students, 25 students from each grade, will go to the next level. There's going to be a Winter Global Challenge. Students from 25 students from each grade of each country, they will be in that. You get a scholarship to go to there. And you can also participate if you want, but there are 25 that get the scholarship to go there. And now you have US and 5 other countries and India. You work on that 3 weeks on a specific project, which is SDG project. And the winners of that, actually, they will go to a global innovation boot camp in the summer. That's an 8-week program, which is done by a Silicon Valley organization called GIC in collaboration with the top university in Silicon Valley. And that's where you will learn how to turn what you learn here to model, simulate, prototype, to actually as part of a business that is sustainable and can have the resources to scale, which is called entrepreneurship. Now, what we have here in these 7 weeks, and this is where the whole thing comes together, because our focus in these 7 weeks is there would be a couple of weeks start from Monday till the end of the next Friday. Over these 2 weeks, you're going to get some warm-up activities, and you have the time to register. You have to make sure you register. You will go in, everybody can go register, and you finalize your registration before the end, those that they want to continue. So you will go to the week 3, and in the week 1 and week 2, you'll have some introductory machine. You're going to learn all these step by step. You'll have some fun machines. These are about math and computational thinking. You will have some robotics machines. You'll learn how to move things around. From week 3, after the registration is closed, then you're going to get additional machine, which is math puzzles. Those are going to be aligned with your standard in India about the math courses that you have. These are all grade specific. There would be some CS machine, some computer science machine. Again, it's not about the language. Is it Python or Scratch or Java? It's about the fundamental concepts of computer science that you're going to have some. It's aligned with the Computer Science Teacher Association. It's an international association that has curriculum for kindergarten to 12th grade for computer science. And then week 4, you start to create your machines. You will do one machine here. We'll announce the subjects when you get there. There will be some subjects you do. Then the week 5 and the week 6. And the week 7, the last week, you will not get any new activities. It's all about creating your project. It's going to be choose this project that you do at the end is going to be one of these 17 subjects. You can choose any one you want, from no poverty to responsible consumption, production, or clean water, or climate action, life on land. And these are the 17 sustainable development goals that United Nations has been identified, and is fantastic, because there is no country on earth that is not related to this. There's no community which you can say, well, they don't care about this. There's something that will take your attention and your interest. That would be the project in the last week. Now, from the week 4, we're going to have a leaderboard. How does the leaderboard work? The leaderboard will be 2 parts, half and half. Half of it would be about XPs. You remember, you get coins, you had a multiplier, they get multiplied, become your XP. By end of the 4th week, all the XPs of the activities that provided to you and you played, it gets added up. So that XPs is half of your ranking. The other half is going to be based on the machine that you created. Here is all about creativity. There is no limit. And the machines are going to be judged by, the expert in your schools. And there would be the highest level of it. Actually, there would be some celebrity to be announced that is going to look at the machines. You will do that in week 4. That will give you a leaderboard that announces in week 5. The leaderboard of week 5 will announce in week 6, and week 6 and week 7. And this last machine, the final machine, is actually the one that will be half of the final leaderboard. And the other half of the final ranking is based on the XP you gather about all the machines of provided machines that you have covered. So half of it is all the XP you covered over the week 1 to the end of week 7. And the other half is one final project, which is an SDG machine about one of the sustainable goals. And that eventually there would be a live event on January 9th. There is a Polyfest that those that have the best machines, and those best machines are going to be chosen by to be announced surprise celebrity, which your schools and Inc. together are deciding about it. They're going to be reviewed by that celebrity, and those that their highest ranked machines are going to come in a live streaming like what we have right now and tell the story of their machines. Now, and of course, those winners, as I said, the 25 of each of the grades is going to be able to go to the Winter Global Challenge. If you want to know more about what is this global challenges are about, if you go to our to the polyhub.com, you will see the description of those. We are talking about these 7 weeks right now. You are in it. The next one is the 3-week Global Innovation Challenge. And this one would be actually a 3-week that all is hands-on project-based learning that goes through the steps of design thinking from empathize and define to ideate and prototype and share and test and bring your project to a very sophisticated level, which is simulating what do you think is a good solution for sustainable development goal, a specific one for a specific community. And again, as I mentioned, the winners of that, they get, some of them, the top ones, they get a scholarship to go to this entrepreneurship program that now they understand how to assess opportunities, see the product market fit, business model, go-to-market, product development and planning and metrics. This is actually a very solid entrepreneurship that gets you to the point that now you understand how the startups, how the Googles and Twitters and Facebooks and Moderna that just brought the vaccine out for the COVID, how do they work? How do they have breakthroughs in innovation? Because it's not just about somebody sitting and thinking. There's a lot of execution and thinking about how to make it sustainable and how to make it scalable, go through. And from what I saw, you girls and boys are so smart, you don't need to wait till you get to university or after you graduate from university to start to get an understanding of how you use what you learn in a math or a science or a physics class in real life. The best way is to actually do that now. And when you do it, actually start to make sense. Why even do we learn what we learn? A secret between both of us, don't tell anybody. The reason you're learning what you're learning right now is not the grades. The grades are just a means to kind of, make you motivated. Great, get a good grade, that's good. But if you learn how powerful is what you're learning right now, that's 10 times more motivating than, I want to get an A+. If I can make an innovation, if I can build what I can imagine with learning statistics or with learning algebra, that's much more important than just getting A+, which is, of course, is very important. Let's get that. But you naturally will get your A in your course. Let's focus on what's fun.
Sorry, I also want to just say that, I've been making some notes. One of the things you said, Amir, I want to highlight is that when you go into the job market in the next 3 years, 4 years, 5 years or so, companies are not looking for just somebody who got good grades. They are looking for people who can apply this. They are looking for people who can make sure that they can talk about bigger issues. So it's important for all the students to understand it's not just the subject and the grade, but what does it mean? And that's what this challenge teaches you.
Okay, so I'm going to have a closing. My suggestion is, if you have any questions, can you please write your questions? I will be able to answer maybe a few of those. Write your questions in the chat. And Lakshmi, if you do me a favor and let me know what was the questions, I'll be more than happy to answer those. I have 2 more minutes, and during this, please type in if they have any questions such that I can answer. So to summarize, what's important is to know what's coming. What's coming is, first of all, again, I want to emphasize on something that sometimes we don't appreciate what we have. COVID taught us that, no matter how much money we have or how much military the countries have or how much science and technology the countries have, we all are, at the end, when the COVID come, we all are, vulnerable, and we're all human. We are in the same place, and we don't appreciate all the, means that is provided to us. So what I want to tell you right now is something that you may not know. The speed that your schools are coming together to make this available to you is just mind-boggling. I mean, you see the names of Kenya and US, and we have other countries, Rwanda and Oman and others here. None of those countries were able to do this in about a week turnaround to make sure you can benefit from the challenge in fall, such that in the spring you're in good shape and summer you're in good shape, to not lose that. And that's an amazing thing. I mean, in other countries it has taken at least 2 to 3 weeks, some of them 4 weeks, to get the act together and make this happen. So I want to make sure that you be aware that it's much value to have such schools, and also our partner Inc. and Lakshmi team have been very critical to make this turnaround and make it happen. So what's coming up next is you are going to, I think sometime around Tuesday, you're going to see a site will be up, which instead of, it will be called, is not up right now, will be called indiain.polychallenge.org. This information, you don't need to take any notes. It will come for you. Some site like this will come up. Like, for example, right now there's like a Azerbaijan, and there is like Rwanda, and others are up, or US. For you would be in IN for India.
India Youth Challenge is what you're calling. India
Yes.
Youth Challenge.
Yes, India Youth Challenge. So IN will come up, and then when you go there, you're going to see a similar environment like what I showed you earlier. I'm right now logged in, and in that environment, you're going to be able to register. You will put your information, and you're going to get the first set of activities. So you're going to get activity set 1, and you're going to start to have warm up and introductory machines. You see the introductory machines here, and you're going to play with them. And then the week 2 of it also would be some more warm up. Between week 1 and week 2, you have time to final your registration, and then the week 3 starts, and that's where you will start to get the math puzzle and CS puzzle, in addition to more introduction robotics and fun machines. And that makes you ready such that in week 4, start to make your own machine based on the subjects that we provided to you. And then finally, week 7, you're going to have the full project. I just reviewed for you to answer the question of what's next.
Yeah.
So
I just wanted to, summarize, Amir, what you're saying. Number 1, what we're saying is that it's about learning how to program without any programming language. I mean, how to, now you're going to the future, not just what's happening today, how to use mathematics to go to the future. Secondly, about bigger issues. It's not how do you use math to actually solve world problems. And the third thing is you'll be working with children from all over the world. So now you are in groups. As you keep going up the levels, you're in groups with people from 5, 6, 7 other countries as countries keep adding. So you have a very international exposure. So those are the 3 things. I know there are some questions you want to ask. I've seen some people just come on video. So are there any questions?
do you want to summarize what question you want me to answer, Lakshmi? There are many questions.
I'm asking you. There are no questions posted right now, so I'm just asking.
I see a lot has been come, so they send me privately. So one is that is it a team challenge or individual? Very, very good question. So it actually right now is individual. From spring challenge, it will have a team element. So you will do both in parallel individually, and you have the option of creating team. It's very important, the collaboration. I really appreciate that you asked this question. It is fundamental element of how you can make ideas real. How startups work is to have a team. And that's an element that takes some more development. You're going to have it from spring. Another question is, there any competition to participate? If any, please tell me how to. No, for participation, there's no competition. If you do register, you're going to be able to come in. There is enough room for all. I mean, there is a process of giving information, do your payment, and go through. So that is not an issue. Then the other question is,
I think the key is the time. You need to decide and be part of it soon, so you're not left behind. So we want you to start as quickly as possible, so you can get the most out of this. So the sooner you register and join, the sooner you'll be able to participate.
So there is a question about, is there any introduction or basics such that they can learn? And the answer is yes. Every week, there is nothing to prepare right now. I mean, as of Tuesday, when you have, everything is in the system. You don't need to go somewhere else to learn about it. When you go, you see the activities, there are videos embedded there from the first week that it starts. There are videos talk about introduction, how to go. There is something called Meet Polly, is the first machine that you're going to meet Polly. Polly is this character you see here. And that one actually starts to talk to you and say what's happening. And after that, there are many videos inside the environment. And if you want to go more advanced, there are like more than hundreds of videos on PolyUp extra. But anything you need is embedded there. You'll see it week by week. You don't need to worry about, you're not behind. You're going to see it as it goes.
And that's why I said earlier, as we said earlier, don't worry if you didn't follow everything Amir has said. All this is available for you. It's like a game. You can go as fast as you want. You can take all the time you want. The key is how much you understand. And that's what will come through when you write your programming, when you write your models, when you create the models, etc. So all of you are starting at the same level. So you don't need to worry about it. Once you sign up, all the curriculum, all the courses will be given to you.
So it's very important to tell, because you have to make sure you know this. There is a set of badges and certification you get when you do certain level of activities. You're not competing with others to go get those badges and certification. Is because of your own work. And when you get it, this would be an electronic certification. As you continue the program, you're going to have your higher level of those badges over as many challenges you go forward. And those are actually start to be important indication of your skills to universities, the various things you want to do, because it kind of goes beyond just the grade in few classes. It actually shows a deeper understanding and how you apply it in a real life. So it's a very valuable thing to have as you go through your journey. Another question asked here is, how much time should we put on it? The answer is your choice. This is not a homework. This is exactly like I ask you how much time you should put on a Fortnite or Minecraft. What's the answer? Here, the difference is, by Minecraft and Fortnite, you may not be able to use it as you go forward or build whatever you imagine in real life. Here you can. Is your decision. You can do a little bit, you can do more, you can do much more. However you see fit, have a balance in life. That's another thing we should learn. You have to study, you have to do your homework, those are required. And then put the time on this as much as doesn't hurt your homework or other things that you're doing.
And also what happens, which we have seen, is that as you do this, you learn your math much better also sometimes, by actually working these models, etc. A lot of the things that may be confusing, clear up also. So this is, the good thing is, when you put time into this, it's not like you're playing a game and you're wasting your time. While doing this, you're learning math also. So you're playing a game, you're doing something fun, but you're learning math also. So it's a very creative way to learn math. And if you look at all over the world, everything is changing. It's not just knowing the formula that's enough. It's not just knowing the theory that's enough. You have to be able to apply it. So our goal is, by using this, we want to prepare you for the future in a much better way. And
So
so you can spend as much time as you want on this, or as little time, but make sure whatever time you spend, you're understanding the concepts.
another question that it asks here is, do we need a laptop or we can do it with a mobile? The answer is you can do it with mobile. We suggest to have a laptop when you want to do your projects, to be easier to put more parts. As you saw, you want to connect it together. And there is a registration link has been provided to everyone. So I think there is information, the questions has been asked about how much is registration, things like that. You can just go there and see. So that part is answered. Let me see the last one. Okay, this is very good
And
question.
the other thing I want to tell all of you, we really have to thank Amir and their team, is that because this is in India, we have priced it also in such a way that it is a third, or much less than it is in US and other countries. So they really want to make this affordable for everyone in India. We want as many people from India as possible to participate. So they've really worked hard to give it to us at a price where the winners will get the equal opportunity at the end to go, but they've really reduced the price so that more people can apply from India. So they've done a lot to make sure it's available to as many of you as possible.
And I want to give that credit not only to the Inc. and your school's management, also to those 8 students that they came. They were so good and enthusiastic and knowledgeable, that made us more pushed us more to bring it down. Actually, because we are doing math right, I have to say it's almost 1/5 of what's in US, the pricing that they got for you. So that's very good. Again, you because of your effort, actually this happened, which is great. There is one very important question they ask: would be any hardware or device requirement for this challenge? So although you can do the most advanced robotics that you can think of, I mean, you can do drones, you can do whatever you like because it's virtual, but you can put all the laws of physics in it and you can model it any way you want. But at the same time, there is no hardware required. The only thing you need is a computer to connect to internet. You can do it even with a phone connect to internet, but I suggest for building machines to have a computer makes it easier, because you want a little bit more space to be able to build what you have. One other one, it says, can you use your own Gmail to sign in? There is no issue for signing. There would be one email that is put there. You can put, there is a place to put your parent email also, while they go through registration for this. And the email that you put for yourself is going to become your username to come in. So it should be an email that you get notification through it. And like, for example, if you lose your password, you're going to get that to you. So I think I covered most of it. It's just coming more. Yes, there is somebody asking, can you make games with Polyop? Definitely. I mean, I showed you one example. Actually, I mean, let me say this right now. One of the first 3 weeks, the subject would be build a game. So you are going to actually build a game. The last week would be SDG, but one of the 3 earlier week would be to build your own game. And you can there is a way that you add some chips which you can build like a Nintendo controller. So the machines you build, if you build a machine and share with me, there is, when I turn it on, I see a controller like a Nintendo gamepad, because you put it, and I can control the machine the way you design it. The point is, you are the one that decides every button, what does it do, because you put the expression, the logic, the thought, and the system design behind it. So there's no limit on what the controller does. So not only you can build a game, You can set every controller, again, you're asking, you can set every controller by putting the math expression under that controller. You're going to learn this in the, I think, week 6, I think you're going to learn that.
Yeah.
I think
and as we said, it's sort of the difference between this and any game, playing just a game, is that in a game, you're playing a game that's given to you. Here, you are creating the game. So that means that while playing the game, you're also learning what is the math behind it. How does it work? That's why it's exciting. So you're playing a game as well as making a game.
So in continuation of what Lakshmi said, like in Minecraft, you can build whatever you imagine, but you cannot algorithmically move it. To do that, you have to go do Java or other things. And even when you do that, there are elements of system thinking which is hard to do that. You have to write a lot of code. But here, you actually very simply, even from the simplest one you start, you can bring the dynamic into your game, and you can make the dynamic of your game controller by others. Exactly the way that bunch of programmers, they built a Minecraft game, put it on a server, and you go play. When you play, you haven't made the logic of the game. Here, you are the one that decides about logic of the game, the way that you like the game to be, and you share it.
And also, as we said, the world is going a certain way, okay? And we don't want our children to be left behind, still doing the old-fashioned way of doing things, while the world is moving to this new way of learning the fundamentals and changing the game. So we are really thankful to all of you for showing up here, because this is a movement that we want to start in India, where our children are moving forward on where the world is going, as opposed to just doing where we are today. So that's why we are very excited about this program, to prepare our children for what's coming, and also be able to work with kids from all over the world, and to have an opportunity to work with leaders who will be coming from all over the world to advise them. So this is really our effort to make this as global as possible, and as futuristic as possible, and as skill-based as possible. So the children should learn a lot of new skills, and make it as huge as they want.
Definitely. And again, in a emphasis on what Lakshmi says, it doesn't stop here. It goes through the path of now building your own project in phase 2, which is like in a global innovation challenge. We are very hard at work to enable to have teams. And when we get to have teams, actually one of the ideas we have is to build teams which are global, rather than the classic method that the team in India go against the team in US or against a team in another country. There are ideas about how to build teams that actually every team member is from a different country, and then have those teams do. You kids actually can show collaboration that then maybe UN and other countries learn from you. How can they collaborate on solving the fundamental issues? So that would be so much fun to see.
Okay, I think are we reaching our time limit? Feel free if there are any questions.
Let me just have a last look. I mean, a lot of kids are asking and about how to control this system, and be patient a little bit. That comes in a week 5 and week 6, and you will see. As I said, you are going to be the one that design your own Nintendo controller. So you're going to have a lot of fun doing that. I think there are quite few questions is in that direction. Some of your questions all about the making of about the registration. Again, I think go to that link that they provided, and somebody is asking, is the math totally included in coding? Well, let's put it the other way, that every coding you want to do is included in math. Let me put it this way. There is no programming that you like to do that you cannot represent here. I mean, now I go it the other way. You may not have heard about this word. I want you to know it. There is a concept called Turing machine, which means it comes from Turing, a great computer scientist and mathematician earlier last century, that found some very important result, that when computers are more advanced than a certain level, which actually is very low level, then all computers are equivalent, meaning that if this computer can do some problem solving or algorithm, the other computer can do, and vice versa. Polyop is a Turing machine. So there is no algorithm that a NASA computer can do that Polyop cannot. But the NASA computer will do it much faster. The coding in Polyop is not replacement to learn Java or Python or all those. Those are necessary. Those are more efficient to do those. But to learn computational thinking and design thinking, even for those that they will not do coding, everybody in society in 21st century needs to know computational thinking, systems thinking, design thinking, and have experiential learning. That's a necessity. Even if I become a nurse, become a doctor, become a lawyer, I should know that. But I don't need to know how to code in Python. So that's the fundamental that you have. And then there is no limit. I think it's good if I finish with this picture, because I get a lot of questions about, is this a replacement for coding? And I want to answer that such that everybody sees. So, there is, even today, there is less than 100 million kids around the world in K-12 that they do coding. It's about 70 million, the number. Scratch, Java, Scratch, code.org. Less than 10 million do Java, Python, C++, things like that. And less than 1 million, they're doing physical robotics in K-12. And we have 1.2 billion K-12 kids. All of them need computational thinking, system thinking, design thinking. So the goal is to bring a virtual robotics and math environment like Polyop, that everybody can do this, but this helps you that when you do to block coding, or you go to JavaScript or physical or entrepreneurship, you have the foundation so strong that now you can go faster. So this is not a replacement for any of those. It's actually a foundation that makes you more successful on each and every one of those. And let me stop here, Lakshmi. I think I answered most of the question. There are many of those, but I think the gist of it got answered.
Absolutely, absolutely. And just to wrap up, before we have Ms. Sridevi come back, is that just remember that this is about preparing you for the future. This is about understanding the basics, not just somehow learning the programming language and putting it out, but really understanding the basics. And what we are most excited about is the ability for the children to work with kids from all over the world and also be global citizens, which is what the world is looking for when they want people to create companies, work for companies. They want people who are more global. So this allows us to do that. So we hope all of you come on board and take part in this, because this is a movement we want to have in India. So we have our children not only become the greatest programmers, but become the greatest learners and contribute to sustainable development goals, to communities in your own cities, and also probably your own community. So that's the goal. And with that, I will request Ms. Sridevi to wrap up.
Yes, ma'am. Amir sir and Lakshmi ma'am, thank you very much for this wonderful session. I think children would love enjoying doing this. So I really thank you from the bottom of my heart for presenting such a nice and interesting session. And children, I want to just inform you all, the registration link is available in the chat box, and also it's available at the YouTube. So you can just copy it and you can register for the session. Okay. Right. Okay, so thank you so much once again for this wonderful and interesting session. Okay, children, you can copy the link from there.
Okay, ma'am.
Right.
Okay, ma'am.
Thank you.
Okay. Thank you, children.
Thank you so much, ma'am.
Yeah.
Thank you, ma'am. Bye, ma'am. Bye, teacher.
Bye. Bye.
Good morning and thank you, ma'am. Thank you, ma'am. Bye. Ma'am, the registration link is also available on YouTube.
Yes, yes, it is there. You can take it from there. Or in the chat box.
Okay.
Right now, it is very clearly available. So you can just copy it from the chat box.
Okay, ma'am.
Yeah.